So last time we talked about naming ionic compounds. What about naming covalent compounds? Like this compound here. This is covalent, which you can tell because it is between two nonmetals. Ionic compounds are going to be between a metal and a nonmetal, or a metal and a polyatomic ion, or two polyatomic ions. So this compound has the name tetraphosphorus decoxide. Okay, so you'll see some stuff that we've seen before, like this IDE business. But now it looks like we've added some prefix stuff. Okay, and that's true. We have. Naming covalent compounds is based on prefixes. Okay, so how do we go about doing this? Well, it's going to look a little similar to what we did last time, and you will start at the exact same place. Identify the type of compound, which for a covalent compound, we're just going to call C, because they're covalent. Dot, dot, dot. Okay, so if I'm doing this example here, a compound formed from one carbon and one oxygen atom, step one, identify the type of compound, C. Step two, so we're going to start the name with the atom of the lowest group number, okay? All right, well, lowest group number, remember the group number is up at the top here, so I'm comparing carbon and oxygen. Well, that would be carbon has the lowest group number. What happens if we have like oxygen and sulfur? Then you would start naming with the highest period number. Okay, so it's lowest group number or greatest period. Now, if you're paying very close attention, you'll realize that also means you start with the least electronegative atom. Yeah, putting it all together, huh? Good stuff. All right, so we're going to start with the carbon. Okay, not the oxygen. All right, so how do we do this carbon naming stuffies? The first atom, give the first atom a prefix only if it has more than one, which we don't. Oh, okay, so that's easy. So our name is going, instead of having a prefix monocarbon, which would be the name with the prefix, we don't include mono because we only have one. Now, how do I determine what prefixes to use? Well, on the polyatomic ion chart, right below in the bottom right, you'll notice this group of prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Those are the prefixes you use. I give them to you because I'm awesome. Really, let's not deny that. Okay, now the second atom gets prefix, root of the element, and then IDE. So this root IDE we saw before. Now we just add in the prefix. So that would be mono and then oxide. Okay. However, the O or A of the prefix is dropped if the second atom starts with a vowel. Yeah, so we just don't like this monooxide business because that's kind of a mouthful. So what we do is we take out that O, we drop the O, to make it just monoxide, because that reads a little bit better. Okay, so that's 5, is getting rid of that bad boy. So the name of this compound would be carbon monoxide. Okay, carbon monoxide. Now, one of the things I just want to draw our attention to back at the top here. Now, if we're drawing a formula for an ionic compound, you wouldn't see something like this, right? Because this isn't reduced. But remember that ionic compounds, the formula for an ionic compound means something different than the formula for a covalent compound. So that's just something we've got to keep in our minds as we're moving forwards. Okay. So I got some examples. Okay. So here's example 1. A carbon with 4 chlorines. So we're going to go through, we're going to identify the type of compound. This is covalent, which I can tell because those are both nonmetals. Okay. I'm going to name the carbon first. It's not going to get a prefix, so that's just carbon. Okay. And the second atom is going to get prefix root ide. And chlorine starts with a C, so no vowel, so no dropping stuff. So this is just carbon tetrachloride.